Problem 1935. We have this device they call a velocity selector with a positively charged metal plate and a negatively charged metal plate. Because there's a positive charge and a negative charge, we have an electric field pointing away from positive toward the negative. And the way I have it drawn, that would be the blue lines here downward. They also say there's a magnetic field in the same area pointing into the page, which I've got these red X's here. Now on one end of this thing we take a particle of charge Q and shoot it between the plates with some velocity V. They would like to know what particular speed we have to shoot these particles so that they travel straight through the middle and come out the other side. Well, I suppose that means as they go through this, they need to be in equilibrium. So if I draw a free body diagram of the charge while it's going through the velocity selector, we have an electric force which will be downward, which is equal to QE, but then there's also a magnetic field, and V cross B, fingers point to the right and curl in, makes your thumb point upward. So there will be a magnetic force equal to Q V cross B. Now we know these two are in opposite directions. In order for this poor little charge to remain in equilibrium, then these two forces must be of the same magnitude. So the magnitude of the magnetic force has to equal the magnitude of the electric force, which is Q VB sine theta equals QE. Now the way we have this set up, the velocity of the charge is perpendicular to the magnetic field, so sine of theta is 1. If QVB equals QE. So the actual amount of charge doesn't matter, and if we solve for V, that makes equilibrium. I get E over B. What happens if the velocity is not E over B? If the velocity is bigger, then the magnetic force is larger than the electric force, which means not equilibrium, but that the particle will travel this way and not make it through. On the other hand, if the velocity is too slow, then the magnetic force will be smaller, the electric force dominates, and it accelerates this way, and again doesn't make it through. Only the particles with the velocity exactly equal to E over B are at equilibrium and get all the way through without being diverted. So that's how this thing can be used to select particles of just one particular velocity.